were able to join us for the previous class, the main design that we have for structuring the topics is that it's too large of a topic scope. We're talking about CCIE Data Center specifically. It's too large of a topic scope to fit it into a single 5-day class. So that's why we broke it down into these 3 topic domains, the first of which was the Nexus class that is now available in video-on-demand format. So for those of you that are All Access Pass subscribers, you have access to the streaming videos of that. For anyone who purchased the class individually or is the package for all 3 of those, you have access now to download the videos. Then this week, of course, is storage networking. And then we still have our 3rd follow-up class, which is the unified computing, which is going to be at the end of October with Mark Snow. So I'm taking this week for storage, and then Mark is going to be back for the next section of class, which is the unified computing. Now, a little bit about the general flow of class and what you should expect out of this week versus the other ones. Now, I'm going to assume that everyone has a pretty good understanding of LAN switching and Layer 3 routing. There's not a whole lot that we need to deal with that's related to Layer 3 routing in this portion of the class. There is going to be some topics, of course, we need to talk about in Layer 2 switching and how Fiber Channel integrates with Ethernet, specifically with Fiber Channel over Ethernet. And I'm also going to assume that everyone has a basic understanding of what are the components of storage area networks. So we're not going to be spending tons of time talking about what are disks, what is RAID, what are the NIC cards, host bus adapters, stuff like that. So I'm assuming everyone has just a general understanding of what is storage area networking. What we are mainly going to be focusing on is how do we actually implement this on Nexus NXOS, how do we implement it on the MDS SAN-OS, and then how does this relate to the overall data center design. Now, what this class is not going to assume is that you have an understanding of how to actually do those implementations. So as long as you know what is storage, that's fine. You don't need to be comfortable with actually configuring, zoning, or configuring aliases or whatever other topics we're going to talk about this week. We are going to be spending a lot of time on the command line looking at where this fits in the overall design of data center. How do we configure the technologies? How do we verify them? And then, of course, when we run into problems with them, what are the ways that we can troubleshoot with show commands or debug commands in order to get back to our correctly working functional config? Now, what to expect about this class? As I mentioned, this is specifically within the scope of CCIE Data Center. So we're going to be talking about Nexus switching for Fiber Channel over Ethernet. We're also going to be dealing with the MDS switching both for Fiber Channel and for some of the IP technologies like iSCSI, FCIP. But compared to previously what we saw in Nexus switching and what we're going to see going forward in unified computing, storage overall is a fairly small distribution of the topic domain for CCIE Data Center. So if the data center written exam is any expectation or any indication of what's going to happen in the actual lab exam, then storage is definitely going to be a much smaller piece of the overall puzzle. Now, we will see that when we get to unified computing, we do need to come back and revisit storage because there's some specific implementations of how the fabric interconnects work for UCS, how the server profiles, how boot from SAN works on UCS. So some of those topic domains we're going to be covering in the computing class that are then going to relate back to this class for storage. But the key point here is that this class is not storage. So we're not going to be going into every possible protocol level detail of Fiber Channel. This is not the level of detail that you would expect to see on the CCIE storage exam. And that's one of the reasons that they have not removed that CCIE track. So CCIE storage is still going to be around for a while. As long as the MDS series is around, storage is going to be there. What we're focusing on here in data center mainly is going to be related to converged Ethernet and unified fabric, how we deal with Fiber Channel over Ethernet, but then which of course assumes that we understand how Fiber Channel on its own works. So we're then going to be breaking this particular class down into 3 main topic divisions. The first of which is going to be how does general Fiber Channel switching work? because ultimately we're not going to be able to understand how converged Ethernet works, how unified fabric works, unless we understand how does fiber channel on its own work. So we'll start with fiber channel switching, both on the Nexus 5Ks and the MDS. We'll then talk about some of the IP storage technologies, like extending fiber channel over fiber channel IP, FCIP over long distances, like for our data center interconnect, and also how iSCSI works and how that can integrate into fiber channel. So how can we use the MDS as kind of an iSCSI to fiber channel gateway? And then lastly, how does the converged Ethernet work, or the converged enhanced Ethernet? This is going to be really the main focus of what's going on with data center. So as we know, one of the big design pushes with the Nexus 2K, 5K, 7K is that we're trying to remove the what would be considered now legacy fiber channel from the data center, try to move that over to 10 gig Ethernet. Eventually we're going to be moving forward to 40 gig and 100 gig Ethernet in the future. So really there's no reason that we need to have separate physical infrastructure for the storage traffic than we do the LAN traffic. But again, the key here is that we can't really understand how or why fiber channel over Ethernet works unless we understand how fiber channel on its own works. So then the first of these with the fiber channel switching, what we're going to start with today is just to talk about what's the overall design of fiber channel. So what are the components that go into the storage area network? How do the disk arrays work? How do the switches work? How do the host bus adapters work? Because if we don't really have a high-level overview picture of what we're trying to accomplish, then it gets more complicated or more difficult to try to really understand why we would want to do this in the design, or why we're trying to implement the technology this particular way. We'll also talk about the fiber channel port types today, which can get fairly complicated because there's different roles that the interfaces have in fiber channel, depending on what type of device the switches are connecting to or the end hosts are connecting to. We'll also talk about SAN port channels, which luckily is nowhere near as complicated as virtual port channels that we saw on the Nexus 5K and the 7K. So same type of logic as we had with just regular point-to-point channels. We're now going to carry that over into the SAN world, where we're taking multiple physical fiber channel links and then we're aggregating their bandwidth together into a higher aggregate logical link. We'll talk about how do we do interconnections between the switches, which in the case of the SAN world we call these ISLs, for inter-switch links. We'll see that some of the terminology that we're going to be using this week can get confusing, especially since most of us are coming from a LAN-WAN background, where normally ISL means the Cisco proprietary inter-switch link trunking encapsulation for Ethernet, where in the case of the SAN world, ISL just means a link between two switches in the fabric. Then we have virtual SANs, which is, for the most part, pretty self-explanatory, assuming you already know what a virtual LAN is, or a VLAN in the case of Ethernet. So same type of logic, we're taking what we have as one physical infrastructure and then breaking it down into multiple logical subdivisions based on the virtual SANs as opposed to one physical SAN, or what's sometimes called the SAN islands. We'll then also talk about the fiber channel fabric services, things like how do we get from our physical host addressing, which is the worldwide names, how do we translate that into the actual fiber channel identifiers, and how are we ultimately going to route the traffic through the network. Okay, this is also going to go along with a feature that is really key in fiber channel, which is known as fiber channel zoning. So zoning is going to be similar to access lists for IP or for Ethernet, where it's used to control in the data plane who can send traffic to who. But in the case of the storage world, zoning is really, really important, because if a server is misaddressing someone else's volume of storage, it can cause data corruption, and basically you could lose the entire volume. And we'll get into more details about how zoning works. It's going to be one of the big things that we need to deal with on both the MDS and on the Nexus 5K, whether we're dealing with regular fiber channel switching, whether we're dealing with iSCSI, whether we're dealing with FCOE. Zoning is going to come into play basically for all of these technologies that we are working with. We'll also talk about some security in fiber channel, how things like port security work. This also kind of fits in with zoning about how we're associating which particular host can talk to which particular pieces of storage, or in the fiber channel world, what we call the initiator and the target, where the initiator is your server, like your VMware virtual host, or like your Windows server, your Linux server, and then your target is your actual storage array, like your EMC, your NetApp array, where the actual physical disks exist. So then the next portion is going to be IP-based storage. First of which is going to be the iSCSI protocol, which is completely unrelated to fiber channel. It's basically an alternative way to get our end servers to talk to storage, but as opposed to going over the layer 2 fiber channel network, we're going over the layer 3 IP network. We'll then look at SAN extension with fiber channel over IP. So there are two separate unrelated protocols, iSCSI versus FCIP. FCIP is used for long distance storage area networks, where we're basically taking fiber channel and then putting it inside of TCP, then using our normal TCP windowing and acknowledgements to make sure that we can send the storage reads and writes for a long distance, more so than you would normally be able to do with just your native fiber channel. We'll also talk about storage high availability. Most of this is going to be fairly self-explanatory if you already understand basic high availability from a LAN-WAN point of view, like how do we use the first hop redundancy protocols when we're dealing with FCIP, and also storage security, which again is going to be self-explanatory if you understand how basic layer 2, layer 3 LAN or WAN security works. Then last but not least, we're going to be talking about converged Ethernet. So this is where we have that buzzword, which is the unified fabric. So really this is going to be one of the main design focuses of data center, is how are we getting the storage traffic off of the legacy fiber channel and onto the converged Ethernet network. So now where we're replacing our Ethernet NICs and our fiber channel host bus adapters, we're replacing this with just single 10 gig converged network adapters onto the end servers. And then they're going to use that both for their LAN traffic and for their SAN traffic for storage. So we'll talk about FCOE, of course. We'll also talk about two other technologies that go hand in hand with FCOE, which are the Node Port Virtualizer, or NPV, an N port virtualization. Also the N port ID virtualization, or NPIV, which is going to be used both on the Nexus 5Ks, the MDS, and the fabric interconnects of UCS, so NPV and NPIV go hand in hand, in order to help us scale the storage area network and to help us simplify the overall management of the topology. We'll then also talk about data center bridging, or DCB, and the data center bridging exchange, the DCBX, which essentially is a way for the switches to automatically negotiate with the end hosts, or essentially the fiber channel initiators. What are the capabilities that you have at your network layer? Are you able to support priority flow control? Are you able to support enhanced transmission selection? What is going to happen when I want to send you a pause frame to tell you to stop sending your storage traffic? Because ultimately we need to make sure that when we're moving the SAN traffic onto Ethernet, that we're maintaining that no drop policy that basically the fiber channel network had automatically built into it. So as we're moving from what fiber channel used with the buffer to buffer, or the B2B credits, into an Ethernet world where inherently Ethernet is lossy, we need to deal with that and make sure that when we're sending our traffic out onto the Ethernet network and it is storage, we need to make sure that our writes are not dropped, or that our reads are not dropped. And then this falls into the last domain here, also quality of service. So once we do the DCB exchange with the end host, then how do we actually enforce the QoS, both on the edge switches that are actually going down to the converged network adapters, and then once the traffic goes into the core. So how do we queue traffic on the Nexus 5K, the 7K, to make sure that that Ethernet traffic is not going to be dropped. Now, as I mentioned additionally, another portion of this class is related to the unified computing, to the UCS. So we are going to be covering the UCS storage topics. Mark is going to be talking about this in the next class coming up at the end of October. So things like how do the server profiles work, how do we configure boot from SAN, how does the fabric interconnect work when we're dealing with fiber channel N port virtualization, or NPV mode, versus fiber channel switching mode, because of course those are going to be UCS specific topics. Now, the issue that we're going to run into here, though, is that the order of how you should learn these topics gets a little bit complicated. Because the issue is that you can't really understand how storage works in the scope of UCS until you understand how storage works on its own. But at the same time, you can't understand how storage works in UCS if you don't understand how UCS works. So essentially, the way that we're approaching this is that we're talking about storage now, then we're going to be talking about UCS in the next class, then finally towards the end of that, we're going to be talking about how storage specifically fits into the UCS design. Because just like with fiber channel over Ethernet, we need to understand how fiber channel itself works first before we can really understand how does the converged enhanced Ethernet work, how does the DCB work, how does DCBX work. It doesn't really make sense why we would need that in the design if we really don't understand the fundamentals of the protocols. Okay, any questions up to this point about what the general topic scope is going to be for the class? So as I mentioned, any questions that you have throughout the week, feel free to just type those into the Q&A box. And then either during the individual lectures that we're going through or after the sections, we'll have Q&A and we can come back and revisit any of those particular questions that anyone has. So the next thing we're going to do is to look at within the scope of CCIE Data Center, what is going to be the overall design of storage and how is that going to fit into the blueprint. So if we take a look at Cisco's website, specifically, if you go to cisco.com/go/CCIE, then from here we're going to go to Data Center. Then on the right, the lab exam topics. And then here we have the particular blueprint. Now we saw that most of this we've already covered in the Nexus class, where Nexus is going to be a very large scope of CCIE Data Center. So the first section here, how does layer 2 work in Nexus? How does layer 3 routing work? How does virtual port channels work? How does fabric path work? None of the storage in the network is really going to work unless we have the infrastructure of Nexus L2 and L3 already built. So if we're thinking about this within the scope of actually going to the lab exam and building the network, you're not going to be able to get any of your storage working unless all of the underlying infrastructure is properly built. So you need to make sure to focus on that. Any of the topics that are located in Nexus that you have questions about, make sure you go back and revisit those particular video sections to see how the basic L2, L3 network works. Okay, then as we go down to storage networking, we basically have 3 total bulleted sections here where when we compare this to Nexus or when we compare this to UCS at the bottom, you can see it's not as very large of a topic domain. So we mentioned most of these already. The first section is going to be just how does native fiber channel work. So we need to understand how do we get trunking up, how do we get port channeling up, what are the different port types. So depending on what type of storage arrays we have, is this a fiber channel fabric switch storage array, or does it only support fiber channel in arbitrator loop mode? That's going to affect how we actually talk to the storage. And then from the servers that are actually referencing the storage, the initiators, within the scope of the lab exam, those are going to be either the UCSB servers or the UCSC servers. So the actual initiators, the picture is going to start to solidify a little bit more once we get into UCS. For this particular week, we're going to be using just regular end stations that are not UCS in order to talk to storage. So this would be applicable to any other blade server that you have that is not using MPV or MPIV, maybe your 1U Dell servers or your just gray market servers that you have that are talking to fiber channel or talking to FCOE. So not within the scope of UCS yet. Okay, then we have IP-based storage, says features including high availability, iSCSI, SAN extension, FCIP. We're going to see that this is a very small portion of the scope. It's very, very straightforward to implement iSCSI and fiber channel integration, but again, it assumes that you understand how FC works on its own. So if you don't understand zoning, if you don't understand how do the worldwide names map to the fiber channel IDs, then it's not really going to make sense how you could use iSCSI to even address the fiber channel network. Then the same is going to be true with FCIP. The configuration is basically 5 lines or so in order to get the feature to work. But that assumes that we understand where does FCIP fit into the design and why would you need to use this versus just running native fiber channel over your data center interconnect. So we'll see when we get to some of the details about how FCOE works. We'll see that there are some limitations of where you can run it in the network. So for example, if I were to be using Fabric Path as my data center interconnect, there are some problems with running FCOE over Fabric Path. Or if I'm doing native layer 3 routing and I'm running OTV, it may make more sense to not put my storage traffic into the OTV tunnel and instead put it into a separate FCIP tunnel so that I can use TCP in order to do retransmission or possibly resequencing, or at a minimum to do the congestion management and congestion notification over the data center interconnect. Because OTV, as we talked about in the Nexus class, it doesn't have any type of reliability built into it. So if there's a frame that's dropped in the transit path, OTV is not going to do retransmission because it's not TCP based. As we saw, it was actually a Ethernet over MPLS over GRE tunnel. So with storage, we have some potential problems in the design with that if I'm sending my packets over the DCI and they don't get to the other end, then it's going to be up to the application level, so the actual fiber channel protocol on the server. And that's going to take much more time in order to figure out that a frame was dropped. And we'll get into more details about that, of why you would want to run FCIP versus doing just native fiber channel over your DCI. Okay, the next portion here, it says implementing unified fabric, which mainly is referring to fiber channel over Ethernet. So how do we run basic FCOE? We'll see in comparison to the fiber channel configuration, it's very similar. There's not that many commands that you need to use to get FCOE working, but we need to make sure we understand from a design point of view and from a foundational point of view what's really going on behind the scenes when I turn FCOE on. Another real important point here is going to be the node port virtualization, NPV, which normally is going to be run on your Nexus 5K, or it's going to be run on your UCS Fabric Interconnect that's going upstream towards where the actual storage is located. So whatever your EMC NetApp storage array, where the actual targets are, and this is going to be related to the scalability of the storage network fabric, that as we start to scale the number of fiber channel switches that we're adding to the network, we run into a scalability limitation that's based simply on the addressing of how fiber channel works. And we'll talk about that today when we talk about the fiber channel identifiers. How does the domain ID work versus the area versus the port number? And that's going to play into how many particular devices that we actually can have participating in the fiber channel fabric. So beyond that, we see that the rest of the topics are going to be related to UCS. In UCS, it does talk about here SAN connectivity. So implementing SAN connectivity in a UCS environment, SAN port channels, virtual SANs, trunking, and SAN pinning. So we will be coming back to this when we talk about UCS. There are some important design considerations on how the fabric interconnects work and how we implement what's known as a SAN A, SAN B design, where we have physical separation of the storage traffic in the network. So that if there is a failure of one of the devices in the topology or maybe one of the links, it doesn't necessarily mean that my storage traffic is going to be dropped. Now we'll see that when we're talking about storage in comparison to our normal LAN or WAN traffic, storage is much more susceptible to traffic being lost in the network, because if we're running, let's say, VMware hosts, that the virtual machines are actually having their OS on the SAN. So we're doing boot from SAN, where every time we want to do a write to the disk or read from the disk, we have to talk to the remote storage. If the storage is not available, then you're going to see your Windows servers are going to have blue screen of death, or your Linux servers are going to crash, or your database is going to crash. Because we're essentially taking what used to be the physically directly connected disks to the servers, or what we call direct attached storage, or DAS, and we're now moving that physically onto a network. So we need to make sure that the network communication is always there for the storage. Otherwise, we're going to have some big problems in the actual operation of the topology. Now, another thing we're going to be talking about here is also role-based access control within the scope of the Nexus 5Ks. Because we know that the 5K is not only a LAN switch, so for doing Ethernet switching, virtual port channels, fabric path, but it's also a SAN switch. So we're doing native fiber channel, also doing fiber channel over Ethernet, but in most typical data center designs, there's a separate organizational unit for the LAN team versus the SAN team. So there's engineers that are dedicated to doing the storage design, the day-to-day storage maintenance, and then there's separate engineers that are used for the LAN and WAN maintenance. So this means from an actual operations point of view, we run into some problems because we now have what used to be two separate networks, the LAN and the WAN, and we're now consolidating that onto one single box. So one of the ways that we can deal with that in the Nexus 5Ks is by using role-based access control and specifying what changes can a LAN engineer make on the platform versus the changes that a SAN engineer can make. Because doing something as simple as changing a VLAN on a trunk or maybe shutting a port down in the LAN world could be completely disastrous to the SAN world, where we lose our rights, the servers that are booting off the SAN then crash, and we have all sorts of different problems. So we'll talk about role-based access control within the scope of kind of like security, but it's more like a manageability issue of how we get those two teams to be able to cooperate to manage the devices at the same time. So the next thing we're going to look at is what is the specific hardware that we're using for the storage portion of the exam, and also we'll talk about what is the hardware that we are going to be using this week for the particular class. Now, as we talked about in the Nexus portion of the class, we mainly had three platforms that we're dealing with: the Nexus 7K, the Nexus 5K, and the Nexus 2K. Okay, we also have the Nexus 1000V, but that's really going to be a portion of unified computing, because it's a virtual machine that's going to be running on the UCS chassis. Now, in the case of storage, the first change that we have that we did not have in Nexus switching is that we have the MDS switches. Specifically, they're using the 9222i, which means that it is a fiber channel switch, but the I means that it has IP storage features as well. So iSCSI support as an iSCSI gateway, and then FCIP support for long distance fiber channel over IP is also going to be supported. Now we'll see that from a configuration point of view, MDS version that they are using, which is 522, is actually a version of NXOS. It's not a version of SAN-OS. So the syntax that we've already gone through up to this point in the Nexus 5Ks and the 7Ks is going to be very similar to what we're going to see in the MDS. Now, of course, there's going to be separate syntax for things like doing zoning configuration, doing fiber channel port channels versus Ethernet port channels. But just from a general interface point of view, it's not a completely alien platform. It looks kind of like iOS. It works like Nexus NXOS does because it actually is Nexus OS. So we'll see that from kind of a learning curve point of view, if you have not used MDS before, but you have used Nexus, then it's basically going to be the same thing. Okay, the other one we already saw, which was the Nexus 5548, which was our layer 2 LAN access switch that's normally used for the aggregation of the end of row, where we have our fabric extenders at the top of row that are actually going down to our converged network adapters, down to our end hosts. Then we're using the fabric extender uplinks to the 5Ks, and then the 5Ks are aggregating all the bandwidth together. Now, in the case of storage, when we're going to fabric extenders and then down to the end hosts, we can also be running FCOE over the 10 gig links. So when the fabric extender is the 2232, which is the 10 gig fabric extender, it means that we also support the converged network adapters, the 10 gig E links. So not only can the Nexus 5K be running fiber channel over Ethernet, but it's also a native fiber channel switch. So we'll see that the particular version that we are using this week, which is the 5548UP, has unified ports, which means that each of the individual Ethernet links can also be changed to native fiber channel. Now, from a physical point of view, the other change we would need to make is the optics, because the SFPs for Ethernet are not the same ones as for fiber channel. because the actual layer 1 encapsulation, like the layer 1 encoding that we use for fiber channel, is different than it is for Ethernet. So from a platform point of view, it's the same port. It's just that you need a different optic to go in there in order to address the fiber channel. Okay, we also have the Nexus 7K. The key here is that the Nexus 7K is going to be having the F1 modules, which F1 is going to support FCOE, but the Nexus 7K is not a fiber channel switching platform. So currently there are no native fiber channel interfaces. I did kind of hear through the grapevine that that may be one of the features that's on the roadmap for the future, but as it stands now, it's just an Ethernet switching platform. So we'll see that a little bit later in the week. How does the Nexus 7K fit into the design? But the majority that we're going to be dealing with in the design is the MDS, which is actually attaching directly to the fiber channel storage, and then the Nexus 5K, which is going to be going down to the end host, either to the fiber channel native fiber channel initiators or to the FCOE initiators. Okay, then we have the UCS fabric interconnects, which again we're going to be addressing that later once we get to the actual UCS class. Then on UCS we have a couple different mezzanine cards, which are essentially the converged network adapters that are sending the fiber channel over the Ethernet network. And then we have the data center manager software. Now we didn't look at the DCNM yet up to this point in the scope of Nexus, because really one of the main reasons why you would want to use this software is to manage the storage network. Now from a storage engineer's day-to-day job, one of the main things that they're doing is dealing with adds and removes to the network in the term of zoning. And we're going to be spending a good amount of time talking about zoning. How does it work in native fiber channel? How does it work in fiber channel over Ethernet? But ultimately that is going to control which servers can talk to which resources. And the issue that we run into is that when you're managing a large-scale SAN, it becomes very difficult to do this from the command line, because we're going to be dealing with these very long worldwide port names or worldwide node names that are essentially these 8-byte addresses that we need to associate to each other in order to form what the result is of kind of like an access list in IP. So this means that if you go onto the CLI and you misconfigure your zoning, you could potentially have a catastrophic impact to the entire storage area network. So one of the main reasons why you would want to use the GUI interface, the data center manager, is it makes it a little bit easier to deal with the zoning. And we'll see it's also going to give us a visual overview of what does the fabric look like. So what are the interconnections of where are the targets attached, so our actual disks, and then where are the initiators, which are going to be the end hosts, and ultimately the switches that are connecting them in between there. Okay, so next let's talk about some of the recommended resources that you would want to go through for this particular portion of the blueprint for the data center. Okay, one here that I have listed is a Cisco Press book, which is Introduction to Storage Area Networks. Actually, no, that's not the Cisco Press one. This is the IBM Red Book, which you can see there is available on Safari. These links, I'm going to be posting them later after class, so you'll have access to them. But I would definitely take a look at this one. This talks about just the overall fundamentals of what are SANs, what are the different components, why would you want to use fiber channel, and then the specifics of the protocol. So how does it actually work from a layer 1 point of view, from a layer 2, layer 3 point of view? Because really at the end of the day, a lot of these storage technologies were pioneered by IBM. So you'll see if you go on Safari and just look under the publisher here, IBM Red Books, there are literally hundreds of titles that are related to IBM and storage. So not to get overwhelmed with it though, because there is a very large scope of what IBM has available for storage. This is a kind of a good middle of the road book here, Introduction to Storage Area Networks, that I would definitely take a look at if you're not already very familiar with fiber channel networking. So if you're already a SAN engineer, you've been doing this for 5 years, then you don't really need to look at this. Okay, where this is really applicable is for those of you that are traditionally LAN/WAN engineers. So I understand how Ethernet works. I understand how IP works. I understand how routing and switching logic work. But now I need to take this and transfer that knowledge over to storage networking. So you need to make sure that you're starting from the fundamentals and making sure that you really understand what's going on behind the scenes before you try to shoot for that very top tier, which is going to be the CCIE level topics. Now, as I mentioned, for CCIE Data Center, we're still not as into the detailed scope as CCIE storage. So if we were to compare the storage blueprint versus the CCIE DC one, storage is obviously a lot more focused on storage networking. So there's a bunch of things that we don't need to do, like interoperability. So what if I have an MDS switch that's talking to a Brocade switch? There's some problems from a design point of view of how interoperability works in the SAN world versus the LAN world. Where in the case of LAN, basically everything is standardized. So we use 802.1q trunking. We use 802.3 AD for link aggregation control protocol for forming port channels. So it's a lot easier to do interoperability in the LAN world than it is the SAN world. But in the case of CCIE Data Center, we really don't need to deal with that. Okay, the next one I have here is another IBM book, but it's not an IBM Red book. It's called Storage Networks Explained, and it is this particular book here. You'll also find this one on Safari. I probably would pick up a printed copy of this, though, because it's kind of a difficult read, where the intro to storage area networks, a lot of the sections you can just kind of page through, because it talks about just the generics of what are the features of the disks, what are the features of the HBA, stuff like that. So this is definitely a good one. Here you can see it's also available on Safari. Then the next one I have is Cisco Storage Networking Cookbook. Now this one is actually part of the documentation set. And it's basically, if you look at this, it's like a printout of the documentation pages. But the problem is they don't have this in PDF on Cisco's website anymore. So there is a version of this that is available, but it's for an older release. This particular one here is for 5.2 NXOS and for the SAN OS. That's the one that we're mainly dealing with. So I would definitely recommend to pick up a copy of this. And this one, unfortunately, is not on Safari, but it is on Amazon. It's not that expensive, about 34 bucks here. But basically what it shows is how do you configure all of these topics in the GUI, which is the DCNM, and on the CLI. Now, of course, we are going to be going through the configuration of how do you deal with Nexus, how do you deal with MDS on the command line, but there's really not a great total resource in the documentation of what's the final config for this, or what's the verification that you would want to do. So if you kind of compare the SAN documentation to the LAN documentation, like in how just regular IP routing works. Okay, if I want to configure OSPF, I can go to the iOS documentation and say, just show me the configuration example, what are the steps to configure OSPF? Or what are the steps to configure BGP? In the case of the SAN topics, it's really not that straightforward. You kind of have to piece together from different portions of the documents where the stuff fits in. And there's some really key points that are left out that can kind of leave you there scratching your head. Why is this not working? Or, my output doesn't match theirs, because there's some kind of basic things that they just leave out of the documents that they assume that you already know. But if you're approaching this from the first time, it can definitely be very frustrating to figure out how it works. Okay, the other one then, of course, is going to be the Cisco documentation. So we are going to be referencing this extensively throughout the week as we go through the different topics, both for the MDS and for the 5Ks and the 7Ks, as we deal with the native fiber channel switching, and then also as we deal with the fiber channel over Ethernet switching. So from here we have the design guides, which are going to be good, but you will not have access to these in the lab exam. So for the actual lab exam, just like the other tracks, you're going to be limited to the configuration guides and then to the command references. Now, the other one that I want to make sure to mention here is the Cisco Live virtual site, which is essentially the recordings from a lot of the Cisco Live seminars. So there's a lot of good information on storage networking there. Of course, not as much as like unified communications or Some of just the regular Nexus stuff, like there's a lot of great videos on Fabric Path, on VPCs, on Nexus 7K design. There's not really as many as there are on storage, but there's a couple that I wanted to point out here real quick that definitely are good and that you would want to look at. So if you go to the URL there is ciscolive365.com, and your login here is not your CCO login, but you don't have to pay for this or anything. So if you didn't actually attend Cisco Live, then it's fine. You could just go here and just create an account, and it's the same as creating a CCO account. There's nothing special that you need to do. Okay, so once you get here, go to the session catalog, and you can see all the sessions are listed. What I would do personally is look for the ones that are the video on demands. Then let's just search for, let's say, FCOE. This one here, FCOE for the IP network engineer. I would definitely recommend to take a look at this one. Basically what it is, it's saying that you're a LAN engineer, you're a WAN engineer. So you understand Ethernet, you understand IP, but you're not really familiar with SAN and storage area networking. So how do you transfer that knowledge from the LAN WAN world over to the storage area network world? So a lot of that we're going to be talking about in this class as well, but it's always good to get different perspectives on the topics. So there's this one here, the FCOE for the IP network engineer. There's a couple other ones, operational modes of FCOE deployment. This talks about some of the design limitations of the platforms based on specific versions, what is supported, what is not supported, what are the different topologies that are or are not supported, like VPC, whether we're going down from the 5Ks to the converged network adapters, whether we're going from 5K to fabric extender to the CNAs. There are some features that simply just are not supported based on the hardware design. Then there's some just generic ones like fiber channel over Ethernet on its own. If you also search for BRK-SAN, that's where the storage area network ones should be. So if I say BRK-SAN, there's a couple other ones that are not directly related to FCOE, but just talk about storage. This one here is SAN Core Edge Design Best Practices. And I believe if you uncheck video on demand, there's a couple other ones here that don't have videos, but they do have PDFs that are available there. So you may want to read through those just to see some of the overall design. But definitely don't leave that out as part of your learning process and part of your preparation process. There's a lot of good content that's located there on the Cisco Live site.